Hey, happy Friday, everybody. I'm Sherry Seligson, and we're here for yet another fun conversation and activity that we can do that is science-related, but educational and also fun. We're going to be making some fun stuff today. Want to wait for a couple more people to jump on before we get started with some of the actual big stuff. But today we're going to be talking about the skeletal system and the muscle system, specifically focusing on muscles and joints and how we move. There's lots of different types of muscles in our body, but I want to talk about skeletal muscles today. Those are muscles we have control over. Think about when we want to move our hands. We send a signal from our brain through the nerves to the muscles that make our hand move. And if I want to make my hand wave, I open my hand up and I do the waving. When I want to stop waving, I close it back, right? We also have other muscles that we don't control, things like our heart muscle, which thankfully we don't control. If we had to think about making our heart beat every moment of every day while we're awake, while we're asleep, for our entire lives, we wouldn't survive very long, would we? So thankfully we have involuntary muscles that do that without us thinking about it consciously. And so I want to talk today about the skeletal muscles that we do have control over. And one of the interesting things about skeletal muscles is they're kind of shaped like this. They're called striated muscles. Each cell is shaped like this. And they kind of orient themselves in this manner. And when they contract, it's kind of an all or nothing thing. A skeletal muscle, for example, some people might say, let's say you're going to make a fist and bend our arm this way and make our biceps muscle contract. Well, some people think you're going to do it a little bit and then more and then more, and so the muscle contracts a little bit and then the muscle contracts a little bit more and the muscle contracts a little bit more, but that's not how it works. What really happens is a muscle cell can either contract all the way or not at all. It's an all or nothing kind of thing. What makes us create greater grip or stronger muscle tension is when more of those muscle cells join in. So if we are flexing just a little bit, then just some of our muscles are going to contract. If we flex a lot, then a lot more muscles will contract. What happens is there's tiny little structures inside the cell. When the cell contracts, it goes like this together, and when it comes apart, like this. It's kind of like combs, in and out, in and out, in and out. And so this guy's contracted like this and gets shorter, and this is not contracted, it opens up a bit. And again, they orient themselves like this. Some will contract, some will not. And so it's an all or nothing thing. That's a common misconception. And the degree of flexing comes with the number of cells that join in to contract. Now, another interesting thing about skeletal muscles is they work in conjunction with our joints. We have different kinds of joints. Our skeleton has many different joints. I should have brought my fun skeleton guy out here, but I don't have him right now handy. Anyway, I have a little mini human skeleton. You can see the different joints of the body. But think about how your body works. We have an elbow muscle that moves like this. This is called a hinge joint. It kind of only goes 90 degrees, right? Or maybe 180 if you consider all the way like this, right? But it only goes in this direction. I can't make my elbow turn that way or this way. That would be actually kind of gross and not fun to see. But we also have a ball and socket joint in our shoulder that spins all the way around. We make our shoulder move in a complete 360-degree circle, can't we? Thankfully, we can't do that with all of our joints, or else we have some really freaky motions going on and we can injure ourselves. But I wanted to talk about how the muscles work with the joints. Most muscles are in pairs. They work together in their contracting and extension. And so they're either in flexion, which means they flex tighter, or they extend and relax. They're either in flexion or extension. And you have a flexing muscle and an extension muscle in the pairs. One does the job of tightening up and making the joint contract, and the other relaxes while that one's tight, and then vice versa. And so I want to talk a little bit about how that works and why they have to be in pairs. So I've pulled out some of my kids' old toys. These are Connects. I tell you, some of these building toys are great for science. And so I have this joint. You can think of this as my elbow, okay? This right here would be my elbow, a hinge joint. And it can go back and forth. The muscle, this would be then my biceps muscle on top that makes it go like this, okay? And so when I want to flex my muscle, I am going to contract like this, okay? This muscle, my biceps muscle, contracts, which then pulls the lower arm forward because this has gotten smaller and I'm flexing, okay? But then what? If I have no other muscle, because muscles can only contract, they can't do anything else, they can't push. There's no muscle cells that can push this down. So I have to have another muscle group along the bottom that contracts to pull this down, and I do. I have a triceps. So here is a more proper representation. I've got my biceps muscle on the top that when I pull it, it contracts. You see that? And then when I want to extend my arm, the lower muscle here on the underside of my arm, the triceps, oops, let me hold it down here so it works better. The triceps will then cause it to extend out. So let me do it. We have contracting the biceps and relaxing the triceps, and then we relax the biceps and we contract the triceps. And when we do that, we get that extension. Okay, so the biceps then was called our flexor muscle because it makes us flex. And then the triceps is our extensor muscle, which allows us to extend. Really doing a hard job getting that to extend. There we go, making it extend out. Okay, so you get the idea. We have to have muscles in pairs, flexing and extending. And so muscle groups are oriented beautifully around all of our joints so that they can work together. And we don't even have to think about, okay, when I want to do this, I'm going to make my biceps muscle. I'm not consciously thinking that, but I'm thinking, bring my hand towards my head. And instantly my muscle, my nerve fibers send signals to the biceps muscle. Those fibers contract and my arm goes up like this. And then when I want to stretch out my arm, let's say I'm going to give you a slice of pizza, then my biceps muscle relaxes, my triceps muscle underneath contracts, and that pulls this group of bones down across this joint and makes my hand extend to you. So they work in pairs. Muscles come in all different sizes. The longest muscle we have is the sartorius muscle that starts at our hip and goes down towards our knee. And the smallest muscle that we have is associated with the smallest bone we have, which is in our inner ear, the stapes bone, and that is called the stapesius, which is a nice combination of names, right? So that's kind of how muscles work, and those are the skeletal muscles, which are voluntary muscles. We have control over those. Thankfully, they're not involuntary. But all muscle cells only can contract. They don't push outward. They contract and then they just kind of relax a little bit. So if they're relaxing, they're not able to push or force. That's why they have to be in pairs and oriented groups. Now, when we're talking about joints, it's really fun to think about this because that's where the topic of prosthetics and robotics comes into play. When we're looking at maybe creating a prosthetic for someone, which is an artificial arm or an artificial leg or an artificial hand, scientists study these mechanics of how it works. And so what we're going to do today is we're going to make a robotic finger and then a hand, okay? I'm going to show you how to do this. I also have a hand here, which we'll talk about in a second. But anyway, we're going to start, and what I'm going to use is I've got one of those boba tea straws, which is a little thicker than a regular straw, and it has a larger diameter. And the reason why I'm using this one is because it's easier for you to see, but you certainly can do it with regular drinking straws, okay? You can't use paper ones. You need plastic, and I'll explain why. The first thing we want to do is we want to create our joints. And so what I'm going to do is, you can see on this one that I've already made, I've made two openings here, one here and one here. I've cut two holes. So I'm going to pinch my straw sideways, and then I'm going to cut a notch at a certain point, maybe a third of the way up. I'm going to cut a notch with my scissors halfway in, and then from the top halfway down, and I'll show you what that's like, and then pull out the piece. Do you see that right there? I've cut a notch. I've pinched it in this direction and then cut a notch. And then I'm going to do the same thing another third of the way up. I'm going to cut another notch. I'm pinching it, and then I'm going to cut a notch. And you want to make sure that your notches are lined up with each other along that same orientation of the straw. Let me cut that a little bit more. I'll show you up close again. Okay, can you see how they're oriented in the same spot? If I'm holding the straw this way, they're on this side. This one's on this side. We don't want one on the other side. They have to be lined up like this, because what they're going to do is they're going to bend in the same direction. And if you think about your finger, I'm basically creating a finger. Okay, my finger has two joints in it, one here and one here, and they bend in the same direction, okay? And then when we talk about muscles, we have a muscle group here that contracts when I contract my finger down. And then we have another muscle group at the top here that contracts so that this group will relax while this one contracts. So I get this side contracting and then this side contracting, this side contracting and this side contracting. So you can see how it goes, it works together. Well, to make this, one of the things about using a plastic straw is the muscle group that we're modeling that pulls the straw back up is just the stiffness of the plastic, because the stiffness of the plastic wants to be straight. And so we're taking advantage of that. And so that represents this muscle group on this side of my finger. But I need another muscle group on this side to make it contract downward. And so what we're gonna do, and there's lots of ways you can do this, I'm gonna cut a tiny little hole at the very top here, but you could actually use a stapler as well. And actually I think I cut all the way through it. Well, then I'm gonna do it the other way. I'm gonna use a stapler. So what we're gonna do is we're gonna go ahead and run our, I've got yarn here. You can use yarn, you can use string, you can use twine, and I'm gonna just run it down through my straw. Let's do that again. And we're going to orient it so that the hole that you cut at the top is where you're gonna cut the end of that string. There we go. Okay, so we want to attach it here. We need to fix it up at this point right here. And you can do that by running it through a little hole and tying it, or you can use a stapler and staple it at the top. And that's what I'm going to do, since I messed up my first cut of a hole there, which is absolutely fine. Okay, so the stapler is holding it in place there. And so now when I pull the string, you can see how it causes my finger to bend, all right? This is the contracting one, and then when I want my finger to go straight, I relax the contracting one, and this creates a contraction this way. And so you get this multiple movement here with the two joints. Without the joints, we don't get any movement, right? We have to have those joints, and we have to have the muscle pairs together. And so you can also do it, you can make fingers. You would just make sure that you orient your holes all by putting the different fingers side by side. You can run some tape around it to hold them together. You can use some low temperature hot glue, not high temperature hot glue, because you'll melt your straws. And then when you run the strings through all four, which I have mine stapled at the top, you get 4 fingers bending down. You can even orient a thumb coming out this way, and have a string being pulled in another direction, so that you can actually maybe create a grip. And so have your kids figure out how to do that. You can use these to kind of pick up a ball, or try to make them understand how that process of our hands work, how muscles work in conjunction with the joints, and then how doctors and other scientists work to understand the mechanics of the human body to benefit people who need prosthetics. This is a very rudimentary prosthetic, but this is what they're thinking about. They have to think of lots of components, joints and muscles and muscle groups, and how they make those work together so that you get your prosthetic. And that helps us understand when you break an arm or a leg or pull a muscle or tear a muscle, how we can repair those so that our bodies are in good shape. So think about that as you're doing this. Have some fun this weekend and make some robotic hands. If you do, send me a picture, or pop it down in the comments of this video. And we will join in again next week with more science fun. If you have any suggestions or questions, let us know. We would be happy to try to answer those, or maybe to try a new subject. I'm having a lot of fun with this. As long as we're in quarantine, we're going to keep doing these. And so thank you guys for joining me. I hope you guys have a wonderful, wonderful weekend. And let's see those robots, all right? Have a great day.